Hi. Good morning, everybody.
Just a minute. Just a minute. I'll share your screen as well. Yeah. So we have Anant here. This is Anant Nivarti.
Hi.
Joining us from US. Yes, Anant. You can.
Hi, everyone. My name is Anand Nivarti. I'm a good friend of Sarfraz Ahmad and his classmate. We both studied together at college. Sarfraz is a great student when we were there. Like he was our class topper as well. Okay, by the way. So I want to talk about myself, and then he invited me to talk about the importance of Python, and then where in industry Python is being used, uh, uh, such kind of things. I mean, like how Python will be helpful for your career, all those kind of aspects, right? Like, so I want to go over mm, about myself first. So basically I'm an engineer. Like as you guys heard in the previous talk, they were mentioning soft skills and then technical skills. I'm part of the technical skills guy. I've been working in the technical field for last 18 years, and then my passion is chip design, like silicon design, silicon development. And I have been involved in several chip designs for several semiconductor companies. So my design expertise is primarily building chips for signal processing, general purpose x86 processors, and extremely low power mobile phone designs. Like I was recently working in one of the latest iPhone designs back at Apple, and then post that I moved into designing the processors, HPC class processors for machine learning applications and AI kind of stuff, right? So that's my background, and I have been married and living here in California with my wife Shilpa and kids. So you can find more about myself on LinkedIn or other pages, right? So, if you want to project the slides that I have sent you, or do you want me to share? Sir?
Yeah, I'll come in. Yeah, you want me to share the slides? Yeah. Anant.
Yeah, it will be better if you share.
Okay.
So because we.
I'll do that. Yeah, I'll just overlay it over your screen.
Yeah.
I can minimize this, right? Yeah, I can make it small now. Yeah. Yeah. Go ahead, Anand.
I can't see them.
You want me to? Okay. I'll do that. Sure. I'll share it.
Otherwise, I can share. I don't know if it works. I can share. Just 1 second.
I'll just check if you can. I'm doing it here.
Yeah.
First. Okay, I'm doing. Are you able to see that now?
Yeah, I can see it. Okay, thank you. So go to the next slide, please.
Sure.
So why is Python? I want to talk very briefly. I don't want to take a lot of time, probably 15 minutes, and go about like why Python, and then who uses Python, and then why you should learn, right? Like Python is a very high level programming language. I would say like Python should be a tool that every engineer needs to know. Like, for example, be it like if you are a doctor, or if you are a medical professional, or if you are a data scientist, if you are a chip designer, everybody needs to know these kind of tools for doing their day-to-day job, right? Like these things enable them to do all the tasks quickly, right? It's a high-level programming language with dynamic semantics for different professionals. Python consists of built-in data structures. It comes comes up with vast resources on the internet. Like you can download several packages and then do whatever app things that is needed for your particular application. You can download them and then go ahead programming with that application. It's a pretty simple, easy to use, and then very friendly syntax. The cost of program management and development is reduced because there is a lot of variety of tools available in Python for everybody. Okay, so go to the next slide.
Sure. Yeah.
Okay, why Python? So it's widely adopted across industry. So several companies, they use Python across the industry, and then there are several packages are available for industry. For example, if you want to do a particular task like data mining, right? Like or data, you want to be a data scientist, right? These days, everybody want to be a data scientist. So data scientist, data mining, there are several free applications available. You can just plug in them, and then you can start using them. And then you want to do your PhD thesis, or you want to do your IEEE publication, or you want to do a patent, right? Like you want to produce a lot of plots, lot of data related to a particular research that you are doing. So there are a lot of applications available in Python. You can just plug in them, and then you can easily do it, right? Go to the next slide. Sir?
Yeah. Yeah.
Okay. Who uses it? So I have taken some examples here, right? So data scientists are the largest portion of Python community. So these days, everybody is using machine learning for different applications, like for face detection, you name it, or you name it medical applications, or you name it like autopilot, like for self-driving cars, you name it, anything for that. Everybody is using machine learning applications. So they all use Python for developing their code, right? Like Python comes up with a couple of examples. I have given simple examples here, right? Like it's not this is not a whole list, but I gave a couple of 1 or 2 examples here. Like for example, in a minute or 2, you can download NumPy package, right? And then install it, and then do all the matrix multiplication, complex things. If you were to write it in C++ or something else, it would take like several lines of code to do that particular task. So with this, you can do it in like quickly 1 line, right? And also, for example, way back 18 years back, when myself and Sarfraz, all of us used to study at college, we all used to use like MATLABs and C++ to do matrix multiplication, and then generate lines and lines of code to do that, right? So these days with Python, NumPy, or any other things like other ones are like Theano, TensorFlow, all these things are available for in Python, free of cost. You can download and then deploy them, right? So with TensorFlow, you can train your network, neural network. You can train you can predict, you can initialize your neural network, and then be done with it within probably 20 lines of code. That's it. Your machine learning algorithm is ready, right? That's just coding part. Basically, there is so much math behind it, so much other things which requires probably a master's degree or a PhD thesis to really understand things. But as a tool, if you want to do it, you can do it in minutes with these tools, right? And then there is a lot of game, web development, IoT developers. A lot of people are using these days Python, right? In many ways that people can't imagine, right? And so there are many companies that deploy Python in the organizations. I mean, like this is not any official list, but it's kind of available on the internet as well. So some of the heavy users of Python is like Google, which deploys it all over in their internal to the company. And they freely publish all these things to outsiders as well. Facebook, for example, Theano was heavily used in Facebook for machine learning applications. And then TensorFlow is heavily developed by Google, and then they're there. used everywhere else also, right? Like, and then Instagram, Spotify, Quora, Netflix, Dropbox. And then if you look at like automobiles, like other companies like Tesla, NIO, everybody is using, right? Like you name anybody, they use Python for their machine learning applications. So that's the brief introduction, and then why use it, and then you are in very good hands. Like I know that we all used to go to surf for asking basic questions from Unix to advanced C++ programming questions. Now he's exporting all these areas, right? Like, so you're in right hand. So I'm pretty sure that he's going to answer all the technical questions much better than me. So I want to take a couple of questions if you guys have anything in mind. And then I heard from Surf that you guys are all data mining experts, and then you guys are all working in different companies, various companies, trying to deploy all these tools in your daily work. So I think, to my understanding, like Python is going to be a really helpful tool for you, everybody. I mean, like even my daughter goes to 6th grade. She is also using Python in her class. Okay, by the way, so it's that much popular. Like she started off her schooling with Python and other things. So it's that important for even for kids. So I can't say anything more important than that.
Yeah, thanks a lot, Anant. It was very
Yeah.
useful. You shared us a lot of information about these things. So I'll open it up for questions. You have any questions?
Yeah, sure.
Any question that comes from it need not be based on what he has covered. If anything you have a doubt on what to use. Sure. So Anand, one question we have here is like he's asking, how is Python used in the testing domain, automation testing and things like that, if you can.
Okay, so testing is something. For example, it's a tool, right? Like for example, like if you take a neural network or if you build a machine learning algorithm, everything has to be tested thoroughly before it is deployed. So testing is like 80% of the work if you take any application. So the moment you choose to use Python as the development aspect of any particular application, Python will also be deployed in testing also. So that's my understanding. So I would say
sure,
it's pretty useful, and then you can automate these things very fast if you use these tools. These are like helping tools. If you look at like my primary background, I am a chip designer, right? Like my management or the place where I work, they don't care if I use something a particular language A versus B, right? Like we all end up using these things because these tools will help us fasten the way we do things.
Thanks, and just to add to what he said, see, specifically for test engineering, Python is more like the framework using which you automate your test cases. Okay, so like the example that he gave, so we in any product that you come up with, okay, so you have a bunch of test cases to be written for it. One of the new ways of working, I mean, it's no longer new, it's quite of is agile methodology that we're working on, right? So in agile, what we want to have results as quickly as possible. Yeah. So I have code checked in, and immediately I should know whether this code passes some sanity tests or not. So I don't want human intervention there. The moment someone, and this is where with all this sysadmin kind of job comes in with, where they have all this Jenkins kind of tools and things like that. So Python here is a glue. It's like it stitches all the pieces together. Okay, so someone checks in the code, and Jenkins picks it up and then triggers the build. And the moment the build succeeds, it triggers sanity test for you, or a small set of test cases for you. Okay, now how do you call all those test cases one after the other? How do you check which one passes and which one fails? How do you report saying, so many passed and so many failed? So that's where Python comes in. It is the tool that is used to automate all these test cases to be run one after the other. One of the test cases that you want is, you would have a particular setup to be done. Okay, and then run the test case. But the second test case is come up with a clean scenario, and reset up first, and then run the test case. So you have to do the setup before you run your test cases. So how to clean up, and then clean up the old setup and start a new setup. So all of this needs to be automated. You don't want human intervention here, right? So this is where Python is used, especially in test engineering. Of course, it's very closely related in that sense for agile, because you want to have immediate results as soon as possible, so you can get through this cycle as quickly as possible. That's one of the cases.
Major companies which looking at testing, do they look at personal testing there or developer doing testing?
Very good question.
See, I'm into testing.
Yeah. So
basic scripting. I don't think that is.
Which scripting, VB scripting. Okay. So another question here is like, are the companies nowadays looking for pure test engineers, or are they looking for test engineers who can develop code? Okay. So
developers who are doing testing.
who developers doing testing,
So every company looks for these days. I mean, like, testing is part and parcel of the job, right? Like, so if let's say if I build an iPhone, right, like or some cutting edge product, it won't go into production without testing it, right? Like be it software or iOS or be it anything, testing is extremely important. So it has to be. At the same time, I wouldn't say that somebody just does testing without understanding what they are testing, right? Like there should be some science behind like what they are testing, and then after that you need to have all these skills to test. You have an eye for like detecting where could be the problem and then find out. That's the ultimate goal of any testing, I would say, like be it a software testing or be it any other thing. Like, for example, if you build an autopilot car that is driving itself, right? Like it has to be tested in all possible conditions so that it won't go and crash somewhere, or it won't go and hit somebody. So it needs to be tested with several software test cases, doing like millions and millions of regressions, right? And all the tools that, for example, Sarfraz mentioned, like Jenkins, and then the Python-based testing. So I work in a different, completely industry. I'm a hardware engineer, but we use all those things for our products to be successful. We use Jenkins, we use automated nightly regressions, we use all the Python scripts to do verification of the design, like whatever we are doing. At the same time, we have a background of like, we have fundamentals of physics and other things which we do use for building the chips, right? Like, so it's like part and parcel. Everybody needs to know all these things.
Thanks, Anand. Just to add on to what Anand says, see, I have one student who is a good example for this question that you were asking. He's working in a startup company. Okay, so 2-3 years back is when he started. He started off as a test engineer. Okay, so he was told to write test cases. So he was doing test cases and he was doing automation. So you can say very few companies are actually looking for manual test engineers. Yeah. Okay, they are moving towards automation test engineers. So he joined as an automation. It's a startup company. Like startup companies, you're the peon to the CEO. You have to do everything. So when he started in 6 months' time, less than 6 months' time, he was asked to write unit test cases for code which a developer had written. The developer could not write those unit test cases because he was busy writing the next feature, because he wanted new products to be developed. It's a startup, right? They have to show some results, kind of. So he started writing unit test cases. So this is the developer's job. Okay, and then he later on said he started automating the build process, which is working with Jenkins. He's a test engineer. Okay, and this is what is his job now. So he's doing this, and then after 2 years, he says, "Now I'm a developer." So he says, "Now no longer there is any. I mean, especially in startup companies, there's no longer a job role called as test engineer. There's a test development engineer." Correct. So now this is what companies are looking for, wherein they're looking for test engineers who can develop code. Because when you're writing automation code, you're not testing somebody else's code; you're generating code. Yeah. You're no longer just sitting and saying, "Okay, somebody write the code for me. I'll see whether it works or not." You have to write some code which will test his code. You get
exactly right. There is nothing called
no more
manual testing, right? Eventually, if you want to test something, you need to understand it such that there is no difference between a developer and tester eventually, right? Like that's what people look for, at least in the companies which are like, as Sarfraz mentioned, like startup companies, and then that's what everybody looks for here, at least in the corporate world here, right? Like whatever I have seen.
Yeah.
Just to give an example from
Sure.
my life, I mean, from my
Sure.
daily.
Yeah, work what you're doing. Okay.
So basically, my company is not a startup.
Okay.
But at the same time, it's not a big company.
Right. Okay.
So it's like a medium-sized company.
Sure,
And
SME,
it's pretty good. So
Okay.
So the people in these companies, like once they get into profile testing, they don't have much scope to go into development.
Right.
So that's why I asked the question, like once I come out, or if I plan to learn something new,
Okay.
how will it affect me as a, because my profile will be as a test analyst.
Correct.
I am not going to get the developer word at all in my profile.
True.
So when you say Python is also used in testing,
Correct.
I want to know like how these companies, the other big companies, or the companies using Python, how do they look at the other person as a test analyst? Like when person goes for interview, right?
Yeah.
They'll see my profile as a test analyst.
Correct.
So they'll say, we don't want a test analyst, we want a developer.
Okay.
So in that analysis, like how do I approach the industry for them?
Definitely a good question. So I'll take that question, Anand. Basically, he's asking, what if he goes for an interview to a company, and the company says we are looking for automation test engineer, and his resume just says he's a test analyst. So how should he approach that? I'll take that question on your behalf.
Yeah.
Okay. So see, it's a good example for that. Okay. So I came to Gopal sir and said, I want to teach. He said, what have you done? He said, I've done development for 12 years. He said, when did you teach? Correct. So that's what he was like. So you tell me when did you teach, so I will hire you. How do I say that? Right? I said, see, I bring the 12 years experience which no other trainer has. What you bring to the table is your set of testing domain knowledge, which no developer has. A developer knows how to write the code, but he doesn't know why to write that code. How should I test this? What are the boundary cases for this? What is black box testing? What is white box testing? Who knows the theory? A test analyst. Now you add Python to it. Now you are the top person who every company wants to pick you on, because you're coming with your deep knowledge about test engineering, and you've added the icing on the cake, which is I can also write code. A developer only knows how to write code. He doesn't understand testing. Not up to that. He can do unit testing. Correct? He needs to learn these skills. How do you gain these skills? 5 years experience, 6 years experience. How do you learn coding? 5 months experience, which is easy to gain. Correct? So you bring to the table what you are good with. So I said, see, I have done teaching in my group. In my team, I have taught people. Like, what was the response on that? Based on that is what he has selected. I'm assuming. Right? So see, this is what I bring to the table for him. For the interview, you bring what is you are capable of doing. What is your capacity? What are your capabilities? What you have which distinguish you from the others. Right? You have 6 years experience. You have so many experience of test analysis. Right? So yes, this is what I bring. Along with this, I can pick up testing, writing code. So that will add more value to what you have already done. What matters in the interview is your confidence of how you portray yourself. What are you confident and what you bring to the table? It's not about what the other guy is expecting. I usually tell, interview is like matchmaking. What happens in a marriage? A girl always says you should be 6 feet. I am 5 feet only. What to do? I said, this is what I have. You like me or hate me, it's your choice. Right? You bring what you are good at. Get me? So you add extra skills, what you can add very easily. That will add more value to what you already have. And so that's what I would usually suggest for you. We'll move on to the next question. Yeah, you tell me, I'll repeat it for you. No problem.
Okay. So, hi Anand. So this is related to semiconductor industry. I'm also working into that.
Okay, Anand, were you able to hear that?
Yeah.
You're able to hear?
Yeah, I can hear him, but if I can't completely hear, I will ask you to repeat the question.
So I'll ask him to come here. He's working in the semiconductor industry.
Oh, nice.
So yeah, Anand, what I wanted to ask is like, how is this machine learning and all this data science being implemented into VLSI actually? So currently I'm working as a CAD engineer or design automation. So what I've seen in VLSI.
Oh, nice.
Yeah.
Okay. So yeah, what I've seen is it's either tool development or the design like physical design or front-end design or back-end design. But where is this machine learning thing? And if I want to shape my career 5-6 years down the line, currently I'm 2.5 years experience into VLSI. So if I see my career like going into that kind of thing where ASIC is being combined with machine learning, so how do I go from here, or what is the correct path?
Okay, I can briefly answer your question, right? Like semiconductor industry has been heavily dependent on transistor shrinking, and Intel heavily markets it all as Moore's law, right? So which is kind of getting more and more difficult. But what happened of late is the applications like machine learning and neural network based. For example, if you look at any of the autopilot hardware, or any of the, for example, neural networks that are running in the Google clouds or something like that, they are extremely heavy compute machines. In the sense, like they are like extremely high performance server class machines, like heavy number crunching. So the industry is shifting towards like workloads which are like in the past more dependent on, for example, like say last 7-8 years have been like mobile phone development kind of workloads, where people doing like very low power chip designs, and then later on nowadays the things are shifting towards machine learning kind of things, like extremely high performance MATML. They can put in a huge server racks with millions and millions of servers with liquid cooling and AC or everything, you name it, anything, right? Like thermal solutions, but they want compute. There is a demand for compute, and then definitely Python is something that you would definitely need it for building all these things. Like, for example, NVIDIA heavily deploys CUDA packages converted from Python TensorFlow into their hardware graphics processors, right? So something like machine learning is something is driving all these new things. The semiconductor industry is not going to see a dead end with this, and then on the consumer side, like all these IoT kind of devices are coming, and they are also gathering a lot of data, small devices, right? So there is a traction of building the chips for extremely low power. So there is going to be demand, and every time there is a dead end to any industry, there is new innovation comes in, and then stuff kicks off. So this is some workload that requires a lot of new hardware to be built, in my view. So I don't see any issues. Like if you are a CAD engineer with a background, I would say, like, for example, I talk to Cadence CEO very often, right? Like Aniruddha. So if you want to build your future in CAD, I think you can deploy all these algorithms to doing automation design improvements in CAD itself. I'm pretty sure they are also investing a lot of money in developing the designs tuned with machine learning, basically generating automatic data based on the previous run sets, right? So everybody is working on those things. So there is a huge investment going on in CAD as well with applying these algorithms. So I would say like the Python is a tool that you would need to know for these things.
Okay. Yeah.
Right. I'm not sure if I answered your question, but there is don't get disheartened, and then you'll have bright career, right? Like it's just that you got to adapt yourself as the industry is changing. There is no fancy names like I am a director, manager, senior manager. Those things are all false presumptions. All you need to know is be up ahead of technology and learn them. Then your career will be bright. Don't worry about that in the semiconductor industry or for any other industry.
Yeah, well said, Alan. That's right. I mean, you need to be good with your. I mean, you're an engineer, okay? So you need to be good technically first. Yeah, I agree with that. Just to add to what you said, Anant, I came across this example, so I would like to quote that. So it's like Facebook for that matter, okay? So when I add a photo to my Facebook profile, okay, how does he figure out? I mean, if I take a group photo of all these, I take a group photo of all of you and upload it on Facebook. Facebook suggests me that this person's name is Saurabh, this person's name is Paramjeet. How did he figure this out? He has collected all the photos of this and put it on their servers. Okay, and he uses machine learning algorithm to figure out, okay, if the face cut is like this, maybe he has given his photo.
Yeah, so, Facebook is a very good example that Sarfraz has given. Like, identify a particular person, detect him in millions and millions of images daily that get uploaded. Right? It's not a trivial task. You need extremely super.
quick.
I mean, like high performance supercomputers to do those tasks.
Okay, and now that technology has moved to your palm, which is your smartphone. This is what Google, or you can say, face recognition locking. You have this iPhone where you can unlock your phone using a face recognition, right? So that same power, which is there in huge amount of, I mean, that's what he was trying to say. It takes a lot of calculations. Okay, so it's like each and, I mean, if you have seen the ad, you'll see that the face is actually extracted, part of it, and different points are noted down. Okay, so that's like your big matrix. Okay, you need to multiply that with many other things and then do all that. That's where he is coming with matrix multiplication. Now he's saying all of that is now moved to your smartphone. That power which was there on a big server is now to be done on your smartphone. Look at this. I look at my face on my iPhone and it says, please hold on, I'm trying to find out whether you are Sarfraz or not. How long will I wait for that? The moment I bring the phone in front of my face, I want it to be on. That's the fast, instant stuff that I'm looking for. And it still has to do the same computation. The existing chips don't have that power. Their power needs to be, the power of calculating these things fast has to be improved to increase of the speed. Okay, so that's where these NVIDIA and these other tools are coming in. So they are building out these GPU stuff, right? So that's where it comes in. So that's where the industry with I'm talking of the chip industry in that sense. So it's moving towards that. So that's where, again, all of these things. Like I have one of my friend who she's working in IBM. So IBM is heavily into, so this GPU stuff what we are talking of is not available on IBM hardware platforms. So now they're building in GPU for IBM hardware, for which Python libraries have to be moved to run with IBM hardware. As of now, Python works only with Intel chips and things like that. It's at the low level. Now that has to be moved to IBM software. So that's also Python stuff. So there's like huge things where Python is used. Definitely, I mean, chip industry also it is extremely heavily used. Any other questions? You have anything with your sysadmin or your, you can say, database kind of questions if you had? So can you tell us something about your huge database access things that you use, Anand? How I mean, how is data important for chip industry? I mean, the place where you work or things like that.
Okay, so for example, like the data that I deal with on day-to-day basis, like the file sizes will be in typically gigabytes. Like for example, like one file size can go to 50 gigabytes to 100 gigabytes plus, and then our disk partitions would be like go up to 50 terabytes to 100 terabytes, right? Like, and then for example, like the small chip that you see on iPhone or something like that would require a project-wise like maybe 100 to 200 terabytes of design database size. So that's what I deal with, right? Like, so it's a huge data problem to do any of these things. I'm pretty sure like other areas like banking and these things, and then for example, like as Sarfraz mentioned, right, like Facebook, all these people, they deal with data which is like unimaginable, right? So data sizes are like exploding. Each image everybody uploads, it has to be saved on Google Pages or Google Cloud. It all has to be post-processed in the cloud, and then you're seeing all the places that you go to a temple place, or you go to any place, or you go to take a picture behind in Bangalore somewhere. Like you see the place name tagged there, right? So it's all being run in the servers with what is there behind, right? Like so data sizes are extremely huge these days.
Yeah, that's true. And just telling you from my students who I get from database kind of a background where they come from. See, they see the like you were talking of Jenkins and things like that, right? So Jenkins has got nothing to do with software testing, okay? But now you need this Jenkins kind of stuff for a complete development cycle. So going from coding to testing to deployment kind of stuff. And as part of this, you have infrastructure management. Right, infrastructure management is where you will have all the databases coming up, setting it up. So you want to have a single piece of, like Python again acts like a glue. That's a common thread or that is used to stitch all these different products together. So since everything is in Python, now I don't want to run have a separate PL SQL script, which will be there, which will do this job for me. I want to do everything of that through Python itself. That doesn't make your PL SQL script invalid. It's just to be invoked from Python. Now, when you start invoking it from Python, it becomes slow because it's like you're integrating two different softwares or programming languages, right? So now, why not Python itself do it on its own? So what is the Python way of connecting to a database? Now, that would be more easy to perform. So that's where database, DBAs actually help you. So that's how Python will help you to get into that picture. So it's like everyone has a piece of job to do. Like he will do the chips, and somebody else will develop it. And somebody else will test it, and then somebody else will deploy it. And once it's deployed, now you have to maintain that. So now how do you deploy it? You have to have like one entire network to be maintained. Yeah. Now for that comes the database. So how do you have this database to be, it has to grow. So when it grows, you have to take care of it. So for example, automated database backups, right? You have to trigger it at a particular time. So you have the system which will trigger it, but you need to write the code for doing all this stuff. So that is done using Python. So it's basically like, again, going to something similar to what we did with test automation. Like it is used to automate the processes that you're following. That's where it's very heavily used, coming from the database perspective. Okay, we have any other questions?
How much
Sure.
is used in gaming?
So I have one question for you, Anant. How much Python is used in gaming?
Oh, gaming, it is heavily used in the sense like for example, I worked on the designs for like PS4 and what is that, Microsoft Xbox in the past. So there are a lot of gaming applications that use Python. So the Python, so what NVIDIA and all these companies do is the code will be written at a high level. So gaming is again heavy multiplication and division, right? Like it's heavily into number crunching. So if you look at very carefully, what the gaming program is doing is like rendering an image and then adding different things as fast as it can. So all those applications require, I would say, use NumPy or something like that. And then there are different tools available in the industry. Once you code it in Python high level, after that, things will, the hardware, like companies will take care of things. Like for example, you have something called CUDA, which NVIDIA supports, which can convert the particular Python program into a machine understandable format for the GPUs, right? So that way, everything goes in Python for writing the high-level applications, and then there are a lot of what in a layman's term, lot of macros, definitions, and then application layer definitions are built in Python, which people can use. Okay, so that it is invisible what happens underneath the hood, right? So at the end of the day, a smart engineer wants to build something which is more valuable, right? He doesn't want to spend a lot of time in understanding all these backward things, what they are doing. In such a case, they have all these tools available which convert whatever they write in Python to go and make the game work. So it's heavily used.
Yeah, thanks, Anant. Just to bring it to what we have been discussing. I don't know if you know that machine learning, especially, has grown a lot in these in the past 3-4 years, has been highly influenced by the gaming world. I mean, the gaming world, when we had Xbox and all these things coming up, they used to have a new separate NVIDIA chip that used to be there, right? It's basically for image processing stuff. Okay, so the power of that is what is used by machine learning. Okay, and they found that these fast, see why we need an NVIDIA image processing chip, because the existing chip is not sufficient. It's not fast enough. So we use this for specifically for matrix multiplication kind of stuff, heavy mathematical operations. So that's why you have an NVIDIA chip when it comes to Xbox or something like that. So machine learning is not something new, just come up now. It's been there since 1950s and 60s. Okay, we just that we did not have the hardware and the kind of software that was needed for doing that or realizing it. Once the demand for gaming increased, the power of NVIDIA chips also increased. I mean, this image processing chips. Okay, then the researchers moved from machine learning to say, well, let's use this powerful NVIDIA chip for doing the calculations that we want to do. Okay, and they started doing that. That's how machine learning started seeing a new light now.
It's 11:30.
Oh, sorry. So that's how machine learning started seeing a new light now in this decade. Okay, and now the demand is so high, these NVIDIA chips are considered to be very slow for machine learning. Again, of course, so again, since it's all with like the way he was saying, it's image processing at the end of the day, right? Image processing involves a lot of mathematical calculations.
Yes, and then the best tool available for doing mathematical calculations and any of the database management is Python, right?
Right.
So if you learn that, it's very useful.
It's used across the industry, kind of.
Across the industry, everybody uses it.
Yeah. Sorry. Yeah, it's, of course, that's what TensorFlow and Theano, they are basically for artificial intelligence. Like for example, what is artificial intelligence? Artificial intelligence is basically where the system learns from the environment. So see, for example, he was giving a good example. He was giving of like a self-driving car. Now, when I have a self-driving car, I can teach it and say, if anywhere you see a wood kind of stuff standing in front of you, that's a tree. You should not go near that. You should keep distance from it, right? And then you see a tree which is fallen on the road. Now, how does the system figure out that that's also a tree I should not touch? It learns from the environment. So that's artificial intelligence. Okay, so it's all about getting all the data and then mapping it. This is a vertical tree, this is a horizontal tree. So figuring out that this is also the same stuff and I should not touch over it. Again, there are a lot of calculations for this. So it again, yes, definitely very heavily used in artificial intelligence.
For AI, which is better, like bottom to top or the top?
Yeah, so that we can discuss later. We can see this. Any other questions? Okay, so I have one question for you, Anand. This is from our team here. So what is the ratio of job offers that freshers are getting compared to other technologies in Python? If you can.
Oh yeah, I mean, like I would say, so whichever I would say, like the interviews that I have been thought of taking, right? Like if there are 4 or 5 rounds of interviews, one round will be the coding round, where a person has to basically understand. They can call themselves as a developer or tester or whatever they want to call. They might be calling themselves as Einstein or whatever it is, but people will go through these kind of checks and balances while hiring. So the one round of coding examples most likely would run into Python or basic understanding of how the coding needs to be done. Typically, people touch base with Python. They talk. The language of communication would go into Python typically in the companies. So yeah. Just don't treat Python as a tool that will get you a job. You need to have your own skill set. On top of that, this thing is a must, right? So along with your skill set, if you have these expertises, I think your career would go for a long distance.
Thanks, Anand. Any other questions?
Yeah.
Shall we wind up for now? Okay, thanks a lot, Anand. It was great interacting.
Okay, all right. All the best to everybody, whoever is trying to learn. You are in great hands. Like we all used to go to surf for our questions related to programming, and starting from GVim, I used to remember like Saf used to help me out. So yeah. All the best to everybody. You are in right hands. So hopefully you all will learn a lot from this course. Okay.
Thanks for those kind words, Anand. Embarrassing.
Yeah. Not really, Saf. Okay. Okay, bye-bye.
We really
Yeah.
enjoyed. Thanks for taking out the time for us. It was
Yeah.
informative. We gained a lot of things from you. Thanks.
Yeah, sure.
I'll
Sure.
end the call for now.
Thank you.
Thank you very
Yeah.
much. Bye-bye.